Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, number of senior citizens. So the whole idea of this problem is that we're given these strings where each string is going to have exactly 15 characters. And so it's encoded in such a way where they give us a bunch of unnecessary information in the problem. They basically tell us that the first 10 characters represent something, but who cares what it is because it's not relevant to the problem. Let's actually just skip to what the problem is asking. Each of these strings represents some information about a person, and we want the number of people who are strictly greater than 60 years old. So from each person, we're going to have to extract that information from this encoded data. Now, the encoding is really simple in this case because, like I mentioned, these are strings. So it's not like, in more difficult problems where we have some kind of binary encoded data, which is honestly much more common. That's kind of the whole idea behind like protobufs, but we won't get into system design topics. I'll probably start making videos about those soon though, because there's definitely a lot of overlap with Leetcode and system design that people don't know about. But anyways, next character. So the first 10 characters represent this. The next character, the 11th character, you could think of it, represents this. And then the following two characters at position 12 and 13 represent the age of the person with 2 digits. So I guess we're not going to have anybody who's older than 99 years old. I guess we could have people that are, maybe 7 years old or something where they just have a single digit and the second digit would probably just be 0 in that case. Anyways, that's the idea behind this problem. So if we were to actually map these in terms of indices, 0 through 9 represents that, index 10 represents this, and here indexes 11 through 12 represent the age. So we just need to extract that information from each string, convert it into an integer because these are characters, and then just check, is that greater than 60? If it is, we can keep track of some count or result and then increment that by 1. Since each string is only of length 15, even if we do slicing, it won't change the memory complexity. The overall time complexity is going to be big O of n, just iterating over all of the people, and constant space because we're not using any data structures. So it's going to be kind of hard for me to do this slowly because my brain just wants to do it as quickly as possible, but I'll try to walk you through each line. We're going to have a result, and that's what we're going to return. That's going to keep track of the count. We're going to go through every person. So I'm going to say for D in details, we want to do some kind of comparison, right? We want to convert something into an integer. We want to check if that's greater than 60. And if that's the case, we want to increment the result. And let's not forget to make this a condition. So what do we pass in to here? Well, in Python, it's very easy, actually. We can use slicing. So we want indices 11 and 12. In Python, we can get that like this, 11:13. So this will get 11, 12. It'll stop at 13 and won't include the character at that index. So this will be a string, and it can be converted into an integer like this. Now, this works in Python. I'll quickly prove it to you after I change this to a D, because I don't know why I called it S, but you can see it works. It's about as efficient as we can get it. I will say that in some languages, though, you might need to do something like this, where you want the character at index 11 and you want the character at index 12. Then you might want to concatenate these together. In Python, it's easy to do that. In other languages, you might want to do it differently. And then, that will be your string, and then you can kind of do this. That works as well. As you can see, this time it just happens to be more efficient, but that doesn't really make a difference. It just has to do with Leetcode's, inconsistency. The other thing I want to say, though, is we can actually do this a bit more mathy in terms of getting these digits. Like without using this int function, this is doing a lot of the heavy lifting for us. We can actually solve this problem without using this int function. So I'm going to say we want the digit at the tens place and the digit at the ones place. The second digit is going to be the one in the ones place, and this is going to be the tens place. So to convert this into an integer, we can get this character and take the ASCII value of that character. And from it, we can subtract the ASCII value of 0. So if this were 0 itself, this equation would evaluate to 0. If this was the character 1, this would evaluate to 1. If this was 9, this would evaluate to 9. So this will be an integer. This tells us the tens place. And we can kind of do the same thing over here to get the ones place, like this. So ord of that and subtracting ord of 0. And now to get the integer itself, which we're going to call the age, we can do it like this. 1, which is just the ones place, that's nothing crazy, plus the tens place times 10. Because if we had 4 in the tens place, we want that to represent 40, and the ones place will stay the same. So this will be the age of the person, and then down here, we can just take the age, check if it's greater than 60, as we were doing before. I'll run this for you. And you can see it works as well. Again, the runtimes are pretty random. I hope this was helpful. If it was, check out Leetcode.io for a lot more, and I'll see you soon.